V be a finite dimensional vector space over K. This V is finite dimensional vector space over K, and W is a subspace of V over the same field K. Then four options are given to you and you have to find which one is true. Actually, in option A, B, C or D, there is quotient space. And how to find dimension of quotient space? Suppose V over W. So this one dimension is equals to dimension of V minus dimension of W, and this is only true in the case of finite dimensional vector space. In option A, dimension of W over V means quotient space W over V cannot be defined because of in our part vector space should be there and subspace in below. This is true only in the case of when they are trivial, means V equals to W. And in this case, option A might be true or might not be true. It means option A will be discarded here because of dimension of W over V you cannot find always. Now come to the option B. Dimension of W, this is right hand side, minus dimension of V over W will equals to dimension of W minus dimension of V minus dimension of W. This one equals to 2 times dimension of W minus dimension of V not equals to dimension of V. So option B discard here, and if you assign values, suppose dimension of V equals to 3 and dimension of W equals to 2, these two value will not satisfy this equation. Now come to the option C. Dimension of W plus dimension of V over W will equals to dimension of W plus dimension of V minus dimension of W. Dimension of W cancel out by dimension of W, and we have dimension of V which is same as left hand side. So option C is correct, and the remaining one option is dimension of V equals to dimension of V over W. We have to check this one. Right hand side can be written as dimension of V minus the dimension of W, and this one cannot same as dimension of V. So option D is also discard. So correct option is option C.